Okay, this is the instruction of how to do addition or systems of equations utilizing addition. And we're going to use the addition technique in order to eliminate one of the variables. Much like the substitution method, we substituted one value in for the other, which gave us only one variable. So in this example, we have two equations. They happen to be, in this case, in standard form. It doesn't really matter what form they're in. We just need the variables to be on the same side. The variable that we're going to cancel needs to be on the same side of the equal sign. That's one of the most important concepts of this, or aspects of that. So if we draw this line and we add them in columns, what we would do is we would take this first column, our x's, and we would combine them or add them. So you have a negative 3x and a 2x, which makes negative x. And then we have our other column, which is our y's, and we have negative 7y and positive 7y. And we see that they cancel. Then we have our equal sign. So we're going to insert our equal sign. And then we have our third column, and our third column are our constants. Negative 29 and positive 24 makes negative 5. And now, notice there's only one variable left, and we want to isolate it. We have a negative x. Remember, we're solving for x, not negative x, so we have to get rid of that negative 1 in front. That negative 1 is multiplying, so we could do two things. The most efficient, a high school student, would multiply both sides by negative 1. That's the easiest way, or at least Mr. Mack thinks that's the nicest and most convenient way. So that leaves you with x equals 5. Now, if we wanted to take that and we wanted to, that's not what I wanted to do. I wanted this part of the equation. No, I don't want that one. I want that one. So let's say we had this and we had to isolate. You could also divide by negative 1. Most 8th grade students are going to do division by 1 because they see that it's multiplying, and the inverse would be division. But notice that still gives you negative x over negative 1 gives you x. Negative 5 over negative 1 gives you 5. So you would have gotten the same answer. It doesn't really matter. Mr. Mack likes multiplying by negative 1 in order to get rid of that. But it's okay, either whichever one you're most comfortable with. But I'm going to erase this so you're not confused on the notes. And so now that we've found our solution for x, we're going to go back and we're going to plug it back in. So we need to plug it back into one of these equations. I'll take the top one in this example. So we have negative 3x minus 7y equals negative 29. And then we're going to plug in x equals 5. So our new equation is negative 3 times 5 minus 7y equals negative 29. Negative 3 times 5 is negative 15, minus 7y equals negative 29. We're going to add 15 to both sides. Add 15, we get negative 7y equals negative 14. And now I will do your method. We're going to divide by negative 7 because negative 7 is multiplying the y. So the inverse would be dividing by negative. I see a lot of students who divide just by 7 thinking it's the opposite. We don't use the term opposite, we use the term inverse. We're not doing the inverse of negative 7, we're doing the inverse of multiplying by negative 7, which is dividing by negative 7. So we get y equals 2. So our solution, written as a coordinate, is 5 comma negative 2. We can go and check that if you want, and it definitely is worth your time and effort. So let's look at the next example. Here we again have our variables on the same side of the equal sign, equaling our constants. So we're going to combine the columns. We're going to combine our x's. And if we combine our x's, let's draw a line here. I like drawing a line just to separate them. 2x and negative 2x, they cancel to make 0. So that's good. That's our objective here. We only use this technique when we eyeball and we see that we can cancel them. If not, we would have to use a different technique. We have y plus 8y, which equals 9y, equals, and now we look at our constants. We have 4 and 14, which makes 18. So notice our variables have canceled. We're left with only one variable. When we have only one variable, we can isolate it and solve it. So we're going to divide both sides by 9. And we get y equals 2. This time we solve for y. So we're going to go back. We're going to pick one of the equations. It doesn't matter. Unlike substitution, it was very important which one we chose. In addition or elimination, we don't have to worry about it. So I'm going to pick the bottom one this time. 8y equals 4. And we're going to substitute this value, y equals 2, in for that equation. So instead of writing negative 2x plus 8y, we're going to write negative 2x plus 8 times 2 equals 4. We're going to simplify before we isolate. Negative 2x plus 16 equals 4. We've simplified both sides. Now we're going to isolate. We're going to isolate x. There are two things happening to it. Something's being added to it, and something is being multiplied. We're going to get rid of the things being added and subtracted first. So we get rid of that 16 that's being added by subtracting 16. That leaves me with negative 2x equals negative 12. And we're going to, negative 2 is multiplying it, so we're going to divide it. We're going to divide by negative 2 on both sides. And we get x equals 6. Remember, our coordinate is x comma y, so I do my x value, then my y value. So 6 comma 2. And it takes about 60 seconds to go back to the original equations and check it. We know it's going to work on the bottom one because we utilized the bottom one to solve. So if we really wanted to check, we could check 2 times 6 is 12, plus 2 is 14. 14 equals the right side 14. So we know that it works for both of these equations. And that's what this solution is. It's a solution to these two equations. The third one, again, we look to make sure, is it set up in the same manner? X, y equals constant. X, y equals constant. Yes. So now we can add the columns. I probably should have done an example where it wasn't, and we're going to have to manipulate it and make sure that they are. Maybe I will create one of those. So I'm going to highlight all the columns. We have x and negative x, they cancel. 4y and negative y makes 3y. And negative 13 and 4 makes 9. And notice how fast and efficient this is. This is a really nice technique when it's set up in this manner because it is relatively quick to solve your system. Okay, I'm going to take the top one this time. And we have x plus 4y equals negative 13. My y value is 3. So x plus 4 times 3 equals negative 13. Simplify it. X plus 12 equals negative 13. We're going to subtract 12 from both sides. And we get x equals negative 25. Ooh, that's a big number. Let's make sure. Now that's a weird number. So I'm going to make sure that I did it correctly because that's a pretty large number. And we've noticed that our numbers, our solutions, tend to be relatively small. So I'm going to go back and check my work real quick, or I'm going to check and make sure that it still works. So the first thing, I'll take this and see, ooh, look at that. I already know I made a mistake somewhere. So I took this, my x value, and plugged it into the bottom equation. That gave me -3. And then I have -25, and it's the opposite of -25. So that would be -3 plus 25 definitely doesn't equal 4. So let's go back. X and -x cancel. 4 and -y. 4y and -y make +3y. Right there, -13. And some of you probably already said that. Hey, Mr. Mack, -13 +4 does not make 9. And you were screaming at the screen. So let's go back and fix all those. And this has to be negative. And this is now going to be a -12. And instead of subtracting 12, we're going to add 12. And that would give me -1. So notice I was aware of something going awry. And my x's. Oh, that maybe is another place where I made a mistake. Good Lord. Mr. Mack may have made multiple mistakes on this one. But we're going to go back, check it real quick. The opposite of -1 is 1. The opposite of -3 is 3. 1 plus 3 is 4. That worked. We have -1 plus 4 times -3 is -12. -1 and -12 makes -13. So great example of why we check our work and we just don't write the answers because we would be wrong in a couple places. Mr. Mack made multiple mistakes. And I could say that I did it on purpose to make a point, but I did not. That was lazy. So great example. This is why we check. Last one, we have x, y equals constant, x, y equals constant. These should be aligned. Very, very important. That's where most students will make their mistakes with adding, is that they are not set up correctly. So make sure that mistake is not made. All right, we have 5x and -5x. They cancel. -y, +8y is 7y. And +1 and -8 makes -7. We're going to divide by 7. Divide by 7. And we get y equals -1. We're going to take any equation. We will take, let's take number 4, let's take the top one, because when we substitute, we're going to have some interesting double negatives here. So my equation is 5x minus y equals 1. So when we plug in this -1, this negative sign is not this negative sign. This says the opposite of my y value. The opposite of my y value would look like this. 5x minus my y value. So I'm going to have minus -1. So we'll simplify that. Ooh, that's a good one. Look at this. -1. -1, we get 5x equals 0. We're going to divide both sides by 5. And we get, divide both sides by 5, and we get x equals 0. 0 divided by 5 is 0. If I eat 0 slices of 5 possible slices, I've eaten 0 slices. So my solution, x comma y, would be 0 comma -1. All right, this should hopefully help you. Well, let's do one. Let's see if we can do one where they require arrangement. Let's see what happens here. Oh yeah, that's a yes. No, that's not a good one. That's not gonna do it. That's not gonna do it either. This is, there we go. There's one. All right, this is a good example. Let's take this example. This is your bonus. This is, if you've made it this far in the video, this is going to help you big time. So we see that we have our y, our x equals our constant, but we have y equals our x and our constant. So let's set it up to the top one. So we're going to move this one. We're going to change this one around. I'm going to rewrite, actually, let's do 2 arrows. We're going to just bring that top one because we're going to put it in the same format. It doesn't have to be x, y. It can be y minus x equals 8. That's okay. It just is the fact that our y and our x are on the same side equals our constant. So we're going to move this. We're going to add 5x to both sides because it's on the right side, and here we have it on the left side of the equal sign. So I'm going to move it over. And the way I move it over is I get rid of it on the right side, it cancels, and it moves over here. So when I rewrite this equation, I'm going to write the y first, then the x, then the constant. And notice that constant, whoops, is negative 20. Don't drop that 20. So now our setup is identical. So we have our y's, we have our x's, we have our constants. So y's, x's, and our constants. And now we're going to add, oops, don't want that type of line, I want that type of line. So 3y negative 5y makes negative 2y. My negative 5x and positive 5x cancel. 8 and negative 20 makes negative 12. We're going to divide both sides by negative 2. Multiply both sides by negative 2. And we get y equals 6. Good. Now we can go back to any of these equations, this one, or this one. I'm going to take the one that I haven't manipulated. That's another little important thing. Use the one that you know is for certain correct. So I'm going to use 3y minus 5x equals 8. I'm going to substitute my y in there, so it becomes 3 times 6 minus 5x equals 8. 3 times 6 is 18. 18 minus 5x equals 8. I'm going to subtract 18 from both sides. And subtract 18. We get negative 5x equals negative 10. We're going to divide both sides by negative 5. Not 5x. I see students do that also. We're trying to isolate the variable so we don't include it. X equals 2. So my solution should be 2, 6. Let's take a second and check it. We use this one, so we're not going to test it with this. Negative 5 times 6 is negative 30. Negative 5 times 2 is negative 10, and negative 20 is negative 30. All right. Come and see me if you have questions. Good luck.